Okay, so we'll be looking at Essential Mathematics Book 2. We're trying to get on speed with geometry and mensuration and looking at revision exercise 3. Essentially, this exercise will focus on questions relating to formal geometry. Formal geometry remains the bedrock for a whole lot of your understanding in geometry. Okay, so just like we said, we're using Essential Mathematics Book 2 and you're on to the MAMU experience. Okay, so it's not more like a very classic MAMU class, so you may not be seeing my face, but that's the idea of this class. You don't need my face, all you need is the content provided in the course of this class. Alright, so we'll take question after question. We'll look at question number 1. Question 1a, and this is the diagram we have. We have this angle as 42. We have this angle as x. We have this angle as what? 92 degrees. So this is what we have. 42x and 92 degrees. That's question 1a. So what do we do? What do we do? Very simple. As a standard practice now for formal geometry, I would choose to name these sides and the angles. I may use them, or I may end up not using them. So I start by saying using notations. As in diagram, you're going to see the importance of this technique much later. You're going to see the importance of this technique much later. So using notation as in diagram, I start with the properties I can easily identify. You discover that from this diagram, A is equal to 92 degrees. If you've seen my videos on geometry, formal geometry, point lines and angles, this gives you a clear description of what I want to talk about. Now, A equal to 92 will mean that this is what? Vertically opposite angles. Beautiful. So A and 92 share a relationship because the lines are intersecting, and so this angle will be equal to this angle. And the reason for that is that they are what? Vertically opposite angles. Now, remember that the objective is that we need to look for x. So how do we get x? I'm seeing a straight line here. I see that this is a straight line. So I can say that 42 plus a plus x will be equal to what? 180 degrees. 42 plus a plus x will be equal to what? 180 degrees. And what's the reason? Formal geometry, you earn your marks by taking or by stating what the reasons are. Now this is what? Angles on a straight line. That will be the shorthand form for writing that. Angles on a straight line. So we know what A is. A is 92. So I'll just simply say 42 plus 92 plus x equal to 180. And that will give me what? I add this together, I'm going to get 134. If I'm right with that, x equal to 180 degrees. And x will be equal to 180 minus 134. And that means x will be equal to what? 46 degrees, if I'm right. Now, notice something that you can put you just put your unit at the end of the problem. You don't need to bother yourself putting units. You just put the unit at the end of the problem. That's where it becomes important for us to state the unit. So that's how that problem is solved. We'll be able to obtain x by simply knowing that what we're dealing with are what? Intersecting lines. And so two key angles come to play here. The vertically opposite angles and your angles on a straight line, forming your property called what? Adjacent angles on a straight line, which will sum up to 180. So that when angles sum up to 180, they form what is called supplementary angles. Alright, so that's taken care of, and we're done with question 1a. Okay, so let's look at question 1b now. Now in 1b, what do we have? We have a diagram that's essentially a triangle. 2a, this is a, and this is what? 141 degrees. 2A, A, and 141 degrees. So how do we go about solving that? Very simple. Now, this is a triangle with a triangle produced with this side produced out. Now, to obtain A, what we simply do is to say that 2A plus A is equal to 141. And the question will be, what's the reason for that? There is a theorem from formal geometry. As a matter of principle, I try as much as possible to tell you this is theorem 1, theorem 2, or theorem 3. I try to allow you to play with the theorems and then understand the implication of the theorem. So I may not tell you this is theorem 1, but there's a theorem that says that if I add the opposite interior angles, it will give me the exterior angle. So we now say this is what? Exterior angle of what? Triangle. Take note of my symbols. Exterior angle of what? Triangle. So that would mean that what? 3A will be equal to 141. I divide both sides by 3, and A will be equal to what? 47 degrees. Alright, so A becomes what? 47 degrees. So you see that your knowledge of the theorem is so important when it comes to solving problems. So that's done with 1 and B. Okay, question 1C. Please notice that I'm also trying to record how I draw, because it's in formal geometry we draw a lot, and it's important to develop the technique of drawing very well, right? So this is more like what the diagram should look like. Okay. This will be 42 degrees. This will be 110 degrees. This line is parallel to this. So we're required to look for angle A. We're required to look for angle A. That's this one. Now, to look for this angle, it means that we should have a way of obtaining this angle. Or look for a way, this angle is given to us as 42, or we should look for a way to obtain this angle. So because those are the angles of interest to me, I'll call this X. I'll call this angle what? Y. This angle X, I'll call this angle what? Y. So please take note that when it comes to formal geometry, there's no particular way of solving. It's a function of what you can see as you start solving. So I saw this and I'm going to work with that. Now, if you look at this, I will start by saying using notations as in diagram. Now, why am I saying that? Because these letters I'm introducing were not given to me in the question. So I am the one introducing those letters. All right. So I'll just split my board here just to create more space for myself. And then you observe that Y plus 42 will be equal to 110. Y plus 42 equal to 110. Remember we said something about what? Exterior angle of what? Triangle. That the interior angles are equal to the exterior. The opposite interior are equal to the what? Exterior. So with that, I will have that Y will be equal to what? 110 minus what? 42 degrees. So if I do my arithmetic right, I should be having 68 degrees. So that's taking care of what? Y. Now, hence I've gotten Y, I can get X. You discover that X plus Y will be equal to 180 degrees. X plus Y will give me what? 180 degrees. Why is that? Angles on a straight line. The angles on a straight line will give me that X plus Y is equal to what? 180 degrees. So if that is understood, I'll come here to say what? That X plus what? 68 will be equal to 180, meaning that X will simply be equal to what? 180 minus 68. And if you do your subtraction right, you're going to get 110. and what? 12 degrees. So I've got 112 degrees. So X is 112 degrees. Now, if you look at these are parallel lines with a transversal cutting through. We said that when parallel lines are being cut by a transversal, 3 to 4 types of angles are identified. We have corresponding, we have allied, and we have what? Alternate. Okay, let's see about 3 major ones. So we can see that A corresponds to X. So we say that A is equal to X, and that's equal to what? 112 degrees. What's the reason for that? Corresponding angles. Remember that corresponding angles will only occur when you have parallel lines being cut by what? A transversal. So that's the solution to question 1C. Okay, so we'll take on the next one. And the next one looks more like this, D. Right. Alright, so that's what the diagram will look like. If you see the construction of the parallel lines, you discover that this figure looks more like a parallelogram, because we know for a parallelogram that parallelogram has opposite sides parallel, and by implication this side will be equal to this side and this side will be equal to this side. But that's not the property we're exploring here. We're exploring that of the sides being parallel. So we can say that from this diagram, so using notations as in diagram, in this case the notations are given to us, we will discover that D is equal to 78 degrees. What's the reason? Corresponding angles. I learned from some students in my class that we call these F angles. F. You see, this is more like the letter F. So when this angle relates to this angle, we say that it's what? Corresponding. Now, if you look at D plus C, we can say they're equal to 180 degrees. What's the reason for that? Allied angles. Now, by the concept of allied angles, if this line is parallel to this line, or in this setup, this line is parallel to this line, and is cut by a transversal, we say that the sum of these two angles must be what? Supplementary. So if I know D, which is 78, then I can simply say that C will be what? 180 minus 78. And that will give me what? 102 degrees. So 102 degrees will be the